left off. So we basically, what we did is we talked about on-click happens. This is a UI event, right? What we then do is we create an async task. We pass the status, some kind of text. It becomes this parameter here. Then we then post, right? Now the result of that is either this text or that text, which then goes into result here, and which is then ultimately just printed out of the screen. That's basically what happens. That's the process in this case, right? Now, to actually show you that this is running truly on a separate thread, let's introduce a tool. The tool is called Traceview, and it's useful for profiling your apps. Okay, so to use Traceview, you need to have a trace file. In other words, you need to generate some kind of trace information before you can view it, right? Makes sense. Now, to do that, you need to basically start the tracing on your code between some 2 points, point A and point B, right? So if we are going to profile most of our application, what would be a good place to start? Where would you start method tracing here? What would be a line number where you can sort of start doing something useful?
35.
So what's the first line? What's the first piece of code that executes in our code? Yeah, on create. And then we must call super. So basically, one of the very first lines of code would be like right here, right? So what I'm going to do is I'm going to start method tracing. I'm going to say debug dot start method tracing. You can optionally give it a name, a file name. Okay, so this is going to start tracing our file, our code. Now, what would be a good place for a point B? What's the opposite?
You mean to stop the tracing?
Yeah, to stop the tracing, yeah.
Just at the end of the on-create.
If you remember the life cycle that we talked about yesterday, right? So what's a good place to stop method tracing? It would be I mean, you could do it. I mean, it's arbitrary, right? You could do it there. Technically, the counterpart to on create would be on destroy, right? The problem with that is that we can't cause on destroy to run. We would have to like kind of sit and wait for it to actually get garbage collected and cleaned up and all that. So we don't really have time for that. So an alternative that I'm going to pick is going to be on stop, right? Because I can cause on stop to run. How? Bring something else in front. Like I could click back. I could click home button, right? And just cause home to become the active activity. So then this one that was running would go from running, right? And it would basically go this way to here and it would sit and stop, right? So that's not a bad choice. Cool. So I'm gonna put on stop here. Now, again, you can type if you like typing. Or you can go source, override implement methods, and find on stop here. Now it's a much bigger list than what you had before, but it's fine. Right, so find on stop, edit, and bam, there it is. So far, so good? Now, what would be the opposite of start method tracing? Debug.start method tracing would be what? Yeah, so debug.stop method tracing. Oops. So far so good. So we basically introduced point A to start tracing, point B to stop tracing. Between those 2 points we should have a file. So I'm gonna run this and it's gonna crash, right? So when you see the error message like this, it means go read the logcat. There's my logcat, and why do you guys think it crashed? So there's my reason for crashing. Yeah, so we need a permission to access the file, to write to file storage. So just like before for internet, you need a permission now again as well. So the permission is going to be called the write external storage. So go ahead and add it. So basically, just like before, we go to the manifest file, right? And just like before, you can say, oops, you can do, I'm going to add it from command line, from text for change, right? But I can say use this permission, Android name. You can copy paste the previous stuff, right, if you want. And then you just have to find the right permission. And I give you a hint, it's called write external storage. And it's somewhere at the end, write external storage. So that's the one. But the key is it's uses permission, not permission. So anybody ran this? Good, it didn't crash, right? So far. Okay, good. Read the logcat, right? Read the logcat. What does it say? So, okay, I'll take a look at it in a second. So if I post something, if I say hello with Traceview, right? And I click on update, right? Now, if you actually, I'm still on this screen, but if I go back and if I go to the DDMS perspective and look at the file explorer, notice that now on the SD card, we actually have a new file called yamba.trace. It's got, hmm? No. 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 No, this is a trace of the code. Alright, so this is a file, but notice that the file is 0. Yeah. That's because file gets created when point A happens. It doesn't get written to until point B happens. Okay? So let's write the point B. So what I'm going to do is I'm going to simply click on a home screen to leave this app. That should cause on stop to happen. All right, so we now have a file. It's actually a large file.
So this is a text file?
Yeah, this is a text file. It's somewhat human readable, actually. So we need to analyze this file, but to analyze it, we need to bring it to our laptop. And right now it's in another computer, it's another device, it's in one of these, right? So how do we get it over from the device into our laptops? Yeah, you can use the there's a button for that, right? You can use the push and pull buttons here, right? So we can select the file, we can do pull get device file and then save it as. So we're pulling it from the device onto our desktop. So if I put it into our Bootcamp, there it is. I'm essentially FTPing it over or something like that, right? So far so good? So, do you guys have a file on your file system? You should be able to go to your workspace, Bootcamp, and then, well, wherever you save it, it doesn't really matter, but there's my file. Right? Now, to analyze it, what I'm going to do is I'm going to say Traceview yamba.trace. On Windows, you may have to specify the full path, Traceview, and then C:\/ blah, 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 the full path. You may have to. That was a known bug before. So basically, what Traceview is a way to see the execution of our code over time, right? So this is basically a timeline, right? So this is our timeline, right? It tells us that the whole thing took 122 milliseconds, or 122 seconds actually, right? It tells us that we had a bunch of threads, right? So this is our main thread, so also known as the UI thread. That's where, you know, all your main stuff happens, like processing of the buttons and drawing of the screen and things like that, right? This is our async task. This is where we actually went and posted stuff online, right? And then we have some other binder threads. There. Okay, so what you can do here is you can zoom in into some areas, right? So if I zoom into this, I can now look for things that were potentially long-running tasks, right? So this was a file descriptor, something to do with POSIX, you know, and so on. I can, for example, zoom in further. I can take a look at various things, figure out what took a while, what are the bottlenecks, and so on and so on. To exit, you double-click on the timeline to reset the view. Yeah.
Also at the function level, you can see.
Yeah, you can see at the function level. So you can see that this whole thing, took, you know, well, whatever I have selected, took 43% of CPU time. Took that long. You know, there were so many recursive calls and so many function calls. There's the top, right? So the top level, 100% took that long, right? So you can basically see what happened behind the scenes in your code. What the steps of execution are. Okay. You can also do a search. So for example, set status. Search doesn't work. It doesn't work for me. There's my post to Twitter. Took 6.2%, right? And doing background, and it took so many milliseconds, right? Okay, so this is a useful tool for looking for problems, also looking at threads. Now, a lot of these other threads, you guys don't know what they are, and you don't really care about them. So none of that, right? So this is what we caused, that one and that one. That's the main stuff that we care about in this case. Yeah.
If I click the update
status like 10 times, what's the sequence of operation?
Why don't you tell me? Why don't you guys go ahead and click it 10 times and let's see what happens. So here I'm gonna close this. I'm gonna run the test again. So I'm gonna say run. Sorry, go back to Java. Run this. I'm waiting for it to start. This could be the same activity. All right, so I'm gonna do this 3 times, right? I'm gonna click on 1, 2, 3. Yeah, the toast is gonna be sequential, but we don't really care about that. That's a UI kind of property. I'm gonna now leave this screen. Okay. And now presumably we have a new trace file. By the way, what you can do is you can also get the trace file via command line. Just 1 second. So you can say, you can do this. Remember ADB? Let me remove Yamba. Oops, Yamba dot, right? So I can do something like this. I can do ADB pull / SD card / Yamba dot trace dot. So this is now pulling that file from command line by ADB. So, although there's a button for that, just to kind of know that it's all really driven by ADB, right? And now I can say Traceview Yamba.trace and see what we get. I'll be there just 1 second. This looks like the same one, right? This doesn't look right. ADB shell CD / SD card RM. So ls the shell RM Yamba trace. Ls the shell gone. Let me try this test again one more time. You know what happens. So, okay. One more time. Okay, so some test. Update. First is going to be successful, but the last one should fail probably because of the repeat messages. Oh, maybe it worked out, I don't know. So I'm going to press home. If I do ls the shell, I don't have the file yet, it's still writing it. There it is. It gets bigger. But there's my file. So if we go here, if we go there, Control D, and if I do pulling that file, tracing it, let's see what we get. Okay, there you go. So basically what we're looking for in here are a couple of things. What's interesting is, first of all, the number of threads that we have going on. So like I said, this is the UI thread. You don't want to be blocking it. Like if we actually had our code run sluggishly, this would be obvious that something is going on here, right? But we already implemented async tasks. So we have these 3 async tasks here, right? That the result of me pressing the button 3 times, okay? So there's nothing really wrong with this code, so that's why, or with this execution, so that's why, you're seeing it like this. But this tool is useful if you think something is running very sluggish. So you don't know why your UI is, for example, not responding, right? So this can reveal that often, this tool. Yes, it can be a little noisy, and there's supposed to be a search that can help you with that, but it doesn't always work, and so on. So again, I just use it for looking for problems, bottlenecks. Okay.
So it's pretty accurate. I mean, in terms of
Yes.
millisecond time.
Yeah, it's pretty accurate. It actually takes into account its own time. So your code may actually have run longer because it accounted for the time that it used to actually write to the trace file. It's going to actually run substantially slower once you have the tracing on. Right?
So he takes that as account.
Yeah. So it takes that into account. So you want to possibly, yeah. So that's taken into account. This 45 seconds and all the timing already took into account the fact that it was running for a while. Okay. So with that, what I would recommend is, now that we know how this works, I would comment this out because I don't want to have it run every single time because I don't need it. So I'm going to comment out this to debug start and debug stop. Okay.